So the first problem we did was a geometry problem, and it was obvious because it asked for a square. This problem, let's read it and see what it's asking about. First of all, are we writing anything down? Nope. And how many times do we read this? 3 times. Good call. Maria and Eduardo are traveling to a business conference. The trip takes 2 hours for Maria and 2.5 hours for Eduardo, since he lives 40 miles farther away. Eduardo travels 5 miles per hour faster than Maria. Find each average rate. Okay, check it out. This problem is dealing with hours. It's talking about a distance away, and it's talking about a rate. So here we are going to use the common formula. Distance is equal to rate times time, because this is a piece of information that we know. The best way to solve this kind of problem is to set up a chart. So we know something about Maria and we know something about Eduardo. We know something about their rate, about their time, and then about their distance. Now, what's my question asking? It says find each average rate. So that's my goal, is to find each average rate. So if I know that's my goal, and when you have a distance problem like this, when you pull out the information, we want to pull it out and put it in a chart. So you put the information in a chart to begin with, and that way you know you're organized and you're set up here. So let's see what we've got. Here's the second time around. Maria and Eduardo are traveling to a business conference. Okay, that's nice. We know the trip takes 2 hours for Maria and 2.5 hours for Eduardo. Okay, so my trip takes 2 hours for Maria and 2.5 hours for Ed, so we're talking about time. So that means Maria is 2 hours and Ed is 2.5. Okay. Ooh, then here's something else. Since Eduardo lives 40 miles farther away. So we're going to come back to that. That's a distance situation. Let's see how that works out. Eduardo travels 5 miles per hour faster than Maria. Okay. So I know Ed is going to travel 5 miles per hour faster than Maria. And then find their average rates. So really the only thing we've got so far that's slapping us in the face are the hours. We have a relationship with my rate and a relationship with my distance. Now check this out. I'm actually having to find 2 things. My question says find each average rate. The deal when you have a linear problem, you only get one variable. So the question is, who gets the variable? Think about this. So Eduardo lives 40 miles farther away. Eduardo travels 5 miles faster than Maria. Typically, your variable is the thing you know the least about. Everything relates back to Maria. He travels farther away than Maria. Travels faster than Maria. So Maria is going to be our let statement. Let M equal Maria's rate. So, underneath the rate column over here in R, M is going to denote Maria's rate. Well, then how do I show Eduardo's rate? He travels 5 miles per hour faster than Maria. So you add to it, exactly. So Maria plus 5 is going to be Ed's rate. Good. Okay, check this out. Now, Maria and Eduardo are traveling to a business conference. The trip takes 2 hours for Maria, 2.5 hours for Ed, since he lives 40 miles farther away. Now, there is my key to my distance. Let's think about what that means. He lives 40 miles farther away. What we really want to look at is we want to get this set up to have Maria's distance equal to Ed's distance. So let's figure this out. If distance is equal to rate times time, what is Maria's distance? 2m. What is Ed's distance? 2.5 times m plus 5. Okay. So, how do we work that 40 miles farther away? Let's draw a chart and see if this helps. If Maria is traveling this far, Ed is traveling this far. How do I make Maria's distance and Ed's distance look the same? I want to basically fill in this gap. So how do I line those up? I'm going to take Maria plus the 40 to equal Ed. Now you could either do Maria plus 40, or if you're so inclined, you can do Ed minus 40. Totally up to you. You have some academic freedom there to figure out what it is that you want to do. Okay, well, let's set this thing up. I'm going to put a little line here to get organized. So Maria's distance is 2m plus 40, and that's going to equal Ed's distance at 2.5 plus m plus 5. Da-da-da-da-da-da. There it is. The big deal with this problem, set up your chart. As soon as you see it starts talking about distance and time and rates, set up your chart. Your ultimate goal is to have the distances equal. So with those distances equal, you have to set that up. Okay, now you just solve. That's no big deal. So you have 2m plus 40. Distribute that 2.5. Gives you 2.5m plus something. What is that? 12.5. Okay? Now, solve. Again, I like to keep my lead coefficient positive, so I'm going to subtract off my 2m, putting that on that side. I'm also going to subtract my 12.5 at the same time, just to get it taken care of. So now I'm left with 40 minus 12.5. What is that? 27.5. Is that right? And then 2.5 minus 2 is 0.5. Okay. So then divide both sides by 0.5. And m in this instance is 55. Awesome. M equals 55. Well, big whoop. What does that actually mean? Hey, we have this super cool thing called a let statement. So, M is equal to 55. We know M is Maria's rate. Cool. So how do we sum this thing up? Therefore, Maria's possessive rate is 55 miles per hour, and Eduardo's rate is what? How do you figure out Eduardo's rate? Yep, add 5 to it. So Eduardo's rate is 60 miles per hour. Awesome. You did it.